This is an Algebra 1 lesson on simplifying rational expressions. So, let's think about rational expressions. A rational expression, in the context that we're using it here, would be the quotient of two expressions. It can be written as a fraction. If you need to, you put a 1 under it like anything else, if it's not already a fraction. And the denominator cannot be 0. This, of course, is always the case with fractions, but it's the case here as well. The denominator cannot be 0, and so each time we do one, we'll need to check to make sure that the denominator is not 0. Okay, that does not mean that the variable cannot be 0. As we work through it. Oh, by the way, write this down to help you learn it. If you have a cipher with you, go ahead and write it down. Otherwise, write it down just to help you learn it. Looking at it, you don't learn it as well as if you write it. So a rational expression is a quotient of two expressions. One of the expressions can be 0. Can be 1. The denominator cannot be 0 because a denominator can never be 0. Never. Okay. Ultimate game over of math. No denominators are 0. So to figure out what makes it 0, act like it is, and then see what happens. Anything that happens in that will be an excluded value. It means that can't be a variable, a value of the variable, even though when you work it out, it looks like it's a good answer. Another thing that we'll do with them, we'll simplify them so that there are no common factors. To do that, we'll factor the numerator and we'll factor the denominator and we'll cancel out the common factors. Okay, let's get started on it here. Okay. Simple, simple. Write this as a fraction. It's a fraction. It's a fraction. It's the quotient of two expressions. In this case, the quotient of two integers. Okay, this is easy. We start getting just a little bit more complicated when we understand that the denominator cannot be 0. So anytime there's a variable in the denominator, we've got to go, wait, that can't be 0. This one's pretty easy. It's just x in the denominator, so we know that x itself cannot be 0. That is the excluded value. X cannot equal 0. Okay, here. Notice if x is 0, it's okay. Because that would be x 0 minus 2. 0 minus 2, which is negative 2. That's perfectly good. The only thing we can't have is the entire denominator being 0. Some part of it can be 0, but when you're done calculating it, the whole thing can't be 0. So what do? We say x minus 2 cannot be 0. We're going to solve it like an equation. And so we'll say x cannot be equal to 2. So if I put in 2 for x, that will be 2 minus 2, which is 0, which is no, can't do that. No, no, no. Okay. Let's look at a few of these and see how that works. Let's work through some and see how it goes. Okay, the excluded values are the values that the variable can't be. That's what I mean when I say excluded values. Okay, so let's look at this one. Okay, the whole denominator cannot be 0. 3x minus 5 cannot be 0. Okay, that means 3x cannot be 5, and that x cannot be 5 over 3. That is the excluded value. It is the whole denominator that can't be 0. The whole denominator, not the variable. Denominator. The individual variable is just fine. For example, here, if x were equal to 0, if the variable were 0, this would be 3 times 3 is 9, minus 5 is 4. And that's okay, The no-no of math is that the whole denominator can't be 0. Here the denominator, oh, why did I say 3? I meant to say 0. I'm sorry. Here, if x is equals to 0, then it's negative 5. So if x is 0, it doesn't matter that the variable is 0. Okay, if x is 0, 3 times 0 is 0, minus 1 is negative 5. So this would be a fraction with x plus 2 over negative 5, and that's perfectly okay. The only thing that won't work is when when x is 5 over 3. So you would have 3 times 5 over 3 minus 5. That's a fraction. We cancel it. We have 5 minus 5, which is 0, which is no. Okay, let's try this one. All right. That's a quadratic. To solve a quadratic, you set it equal to 0. Let's see what happens when we do that. I can factor. Oh, that's not going to work. Because that would be 15 and that'd be 2. That's not going to work. Try the quadratic form, and this just isn't going to work. There are no solutions. There are no solutions to the denominator equals 0, so that means there are no excluded values. Okay, so if you can't solve that equals 0, then there are no excluded values. Okay, how about this one? Okay, let's try it. We got an n minus 6. Oh, look at the bottom. That's a quadratic. I can factor. A times c is negative 24, and b is negative 3. That looks to me like that's going to be negative 8 and positive 3. So I'll go ahead and write that out to find out what my factors are. So here's my negative 8 and my 3. That comes from here. Then I factor by grouping. They both have a 2n. This stuff isn't going away, so the practice is good for you. And she shoots, she scores. The thing in parentheses is the same. So I distribute out the other and group it. Then I find out that this is the denominator. Okay? And that can't equal 0. So that means this one can't equal 0, or this one can't equal 0. And of course, they can't both equal 0 either. So this would be 2n doesn't equal negative 3, or n doesn't equal negative 3 over 2. Here n cannot equal 4. Those are the two excluded values. And this one. Oh, you should notice this. You should recognize this. This is the difference of squares. If you're not used to looking for it, you need to be looking. It's going to pop up all the time. If you don't notice it, you can factor it by I can factor. You can put m squared plus 0m minus 4, and it will work out, and you will get the same thing. And what you will get is m minus 4, m minus 2, and m plus 2. Remember the difference of squares? There's a perfect square, there's a perfect square, and there's the difference. In the factors, it's the square root of them. Square root of m squared is m. The square root of 4 is 2, and 2. So it's m minus 2, m plus 2. Are the factors. Again, this cannot equal 0. That means that either m minus 2 cannot equal 0, which would be m can't equal 2, or m plus 2 can't equal 0, which would be m can't equal negative 2. So m cannot be plus or minus 2. Okay, let's try a few more of them. How about these? Okay, let's go back and remember how we reduce these things, how we can simplify them. Some of you have already got a good eye for this, and some of you need to practice it a little more. So let's put it like, let's make sure that we do it. Remember, you think of the numbers together as a fraction. And you can write it separately. That can help you. And then each of the variables on its own. If there's more than one variable, you make another fraction with the others. Okay, so we're just going to reduce 4 over 22. It's going to be 2 over 12 divided by 2 in here, remember our exponent shortcuts. If you don't remember your exponent short, that's going to be 3 minus 6, which is negative 3, which is 3 on the bottom. Remember that? If you don't remember it, it's a shortcut. Write out the long one. There's a cubed. There's a to the 6th. Because I wrote 6 of them. Because I wrote 3 of them. What's left? 1 over a cubed. Whenever you go have a brain freeze and you can't remember the shortcut, don't just sit there and punt or trill, or if you're in the band or the football team, work it out, write it the long way. Because all it is a shortcut. So that's the simplified version. Again, we have to check for excluded values. We always use the original denominator, although here it wouldn't make a difference, but get in the habit of using the original one. So 22a to the 6 cannot be equal to 0, which means divide both sides by 22. 0 divided by 22, you can do that. Can't divide by 0, but you can divide 0 into pieces. You don't get much. You cannot equal to 0, so a cannot equal to 0. Okay, so that's the excluded value. Okay, let's look at this one. Need to simplify this. Okay, I am not telling you to do this. This is how many of you are going to do it wrong because you're going to forget. You're going to say this. And this isn't just wrong. It's like really, really, really bad wrong. No. When you have like fractions, they have the same denominator. You add the numerator. It doesn't go the other way around. And if you're sitting here saying, but Miss, it seems like it should. Okay, let me show you why it's not. What if I have 3/5? And I want that to be 3 over 2 plus 3, right? Isn't that right? Yeah? 2 plus 3 is 5. That's okay. So then can I say 3 over 2 plus 3 over 3? That is 1 and a half, and 2 and a half. Is 2 and a half the same as 3/5? I think not. You cannot do this. No. Okay. That's as simple as it'll get, so there's nothing to do except figure out what the excluded values are. And so the excluded value, again, take the whole denominator. C plus 5 can't equal 0. C can't equal negative 5. Okay? Okay. Let's look at a few more here. Okay. How are we going to do this? We can't split up the denominator. Okay. I'm going to go ahead and work this out. Why don't y'all work it out with me as I'm doing it? Okay. What I'm going to do first in all these cases is take out the common factors. Divide out the common factors. In the numerator, they both have a 2 and they both have an x. So I'm going to rewrite the numerator, like this. 2x in both of them. What's left from the first one is an x, from the second one is a 4. The denominator, they both have a 3. And then what's left is an x plus 4. Oh, look, how convenient. They both have an x plus 4. Remember, we only cancel the multiplies, but this group is multiplied. This group is multiplied. I'm not canceling addition. I'm canceling the group, which is multiplied by the others. So let's cancel out, and then our final solution here will be 2x over 3. That is the simplified version. A reminder, for our excluded values, we're always going to go back to the original values. Look here. You're going to have a tendency to say, well, there's no variable in the denominator. I'm cool. You're not. If x were something, that's good. The whole denominator is going to be 0, and you'll never get to this. So check for the excluded values. here is our original denominator. 3x plus 12 can't equal 0. 3x can't equal negative 12. X can't equal negative 4. That's my excluded value. So again, if you notice, if x is negative 4, that'll be 3 times negative 4, which is negative 12, plus 12, which is 0. Oh, no, can't have 0. That means you can't have x be negative 4. Notice we don't care if x is 0. It's not the variable we care about. It's the entire denominator. Okay, let's do the next one. Well, there ain't anything to factor out of the numerator, so I'm going to go to the denominator. Okay, so there's my numerator. Let's see what the denominator looks like. Both of those have an 8, and both of them have 2 x's, so that's 8x squared. What's left here would be x, and what's left here would be 2. Again, we might want to break this up and think about it as a fraction, and you can do that by kind of cutting it off here. That would be 8 over 8 times x over x squared times 1 over x plus 2. Again, multiply. How do you multiply fractions? The top times the top times the top. 8 times x times 1. Yes, that's the same as the original. 8 times x squared plus x plus 2. Is that the same as the original? Yes, it is. I haven't changed it. I've just monkeyed it around a little bit so that I can figure out how to reduce it and make it more simple. 8 divided by 8 is 1. X divided by 8, x squared is plain old x, x to the 1. And then there's nothing I can do to simplify that. So what's left? The top times the top times the top is just a 1. The bottom times the bottom times the bottom is x plus 2. Oh, no, there was an x there, sorry. X and then x plus 2. X times x plus 2. So depending upon how you're asked to get the answer, you'll probably usually want it to be like this, but whichever. Okay, excluded values again, you'll take the entire denominator, say it can't equal to 0. Cannot equal 0. Well, we've already factored it. So that can't equal to 0. Remember, we've done this a whole lot of times. That means either that one has to be 0, that one has to be 0. So we know that 8 is not 0. So we'll say that x squared cannot equal 0. I mean, 8 is not 0, so we don't have to do that. And then x plus 2 can't be 0. This means x can't be 0, and that x cannot be negative 2. Those are our excluded values. Okay? Okay. Now, if you would please, pause the lesson and work these. Hit the pause, and I'll put the answers up for you. Okay, here are the answers. Make sure that you're getting them. These are the ones we just practiced. Make sure you can work through them and get the same simplified answer, and make sure you know what the exclusions are. Okay, next up, what are we going to do with that? Okay, well, I'll tell you what's not right. You're not going to put 3c over c and 33 over 11, and you say to yourself, but miss, you just let, no. I only let you do something like that with multiply. You can only do that with multiply because multiply is like the easiest thing. It does not work if there's an addition. This doesn't work. Okay, so what does that mean? Well, I'm going to try to factor the numerator. I see some common stuff there. I see they both have a 3. And when I take that out, I'll have c plus 11. And then the denominator is c plus 11. Oh, how cool. And again, this is like 1 times c plus 11. It's multiplied. And this is 3 times c plus 11. So those do cancel. And then the final answer is 3. Now we need to see what's excluded. C plus 11, the original. You're saying, miss, there isn't even a denominator in the answer. How can anything be excluded? Oh, but they can. Go back to the original. If that original C was negative 11, the whole thing just falls apart and it doesn't work. C cannot be negative 11. Okay? Or you would never get past here to get there because you'd have a 0 in the denominator. And that's the absolute game over. We can't do that. Okay? Let's look at this one. Okay, that's all multiply. So for some people, it helps them to think of it as separate fractions. You'll get to where you can see it without having to write it out like this. And if you're already there, that's good. And if you're not, then practice it. So, then we're going to look for common factors. How could I reduce 27 over 30? I divide them both by 3. This will be 9 times 3 is 27, and this will be 10. Remember our exponent rules. 2 minus 5 is going to be a 3 in the denominator, so this will go away and be 1. Then this will change to 3. 2 minus 5 is negative 3, which is a 3 in the denominator. Okay. So our simplified version here then would be 9 over 10. So then the top times the top goes on the top. The bottom times the bottom goes on the bottom. And that's our simplified answer. What's excluded? Go back to the original. That's a good habit to get in, although in this case it won't make a difference. So 30b to the 5th cannot be equal to 0. Divide both sides by 30. 0 divided by 30 is still 0. No matter how many pieces you chop 0 into, you still get nothing. So b to the 5th cannot equal 0. So b, the 5th root, cannot equal 0. That's your excluded value. Okay? All right, everybody, work these. Pause and work till you get them. And here are the answers, the way I worked them. Okay, let's look at some of them here. Okay. There's nothing you can do with that. That's just to see if you can, if you want to put d over d and 8 over 8. No. This cannot be simplified, but you still need to find the excluded values. 8. That's a positive 8. I did that wrong. D cannot be positive 8. Okay. Second one again. You're going to work through here. There is a common factor, and you do get the same thing. Notice here that it doesn't matter that that's x plus 3 and 3 plus x. Addition is commutative, and they are the same thing. You may want to write them so that it looks the same. If that makes you feel a little more comfortable, particularly when you're first starting, it might be more comfortable for you to write it like this, and then you can see that they'll cancel really easy, and you'll just have 4 over 1 left. Again, the excluded values. Take the whole denominator. It can't be 0, so in this case, x can't be negative 3. Okay, now this one throws a little extra something into it. It's a little bit tricky. As you factor them out, you see that you have two things that look a whole lot alike. There's an f, and there's a 3, and there's a negative. And there's an f and a 3, and there's a negative or a minus. And you're saying like, but that's not the same thing. Addition was commutative, so it didn't matter. Subtraction is not. Okay, well, there's a fix for it. You can remember that everything becomes negative when you multiply it by a negative. It's a flip-flop. If it was positive, now it's negative. If it was negative, it's now positive. That's what we do here. So 3 minus f is the same thing exactly as writing negative 1 times f minus 3. Is that true? Well, let's see. Negative 1 times f is negative f. Yeah, that's there. Negative 1 times negative 3 is positive 3. Yeah, that's a positive. Yeah, it works. Okay, does everybody see it works? So I'll go ahead and write that in here. I'll substitute in my altered version so I can simplify it. And then it simplifies down very nicely to negative 3. Again, we go back to our original to determine what the excluded values are, our original denominator. Okay, let's look at these. Okay, x plus 2 over x minus 4. Ooh, wait. That's a quadratic. That's a perfect square and that's a perfect square. I think we just had this exact same perfect square. And there's a square and a square and it's a difference. It is the difference of squares. You need to learn to see these. It's not going away. It is the difference of squares. So I can rewrite my denominator. I'll just copy the numerator. There's nothing to do with that for the moment. And I can rewrite my denominator as the square root of each one of them. The square root of x squared is x. The square root of 4 is 2. And so that'll be a plus 2 and a minus 2. At this point, it's just like, oh, look, those will cancel. That's a 1. Yeah. So what do I come up with? I come up with 1 over x minus 2. That is my final simplified version. I need to check back about what needs to be excluded. A reminder, the entire denominator, x squared minus 4 cannot equal 0. That's a quadratic, so I have to factor it to be able to figure it out. Oh, wait, I've already factored it, so I'll just copy it down. It's the difference of squares. They're so easy. If you hadn't caught on to it, you need to work on that. So either x plus 2 can't be 0, x minus 2 can't be 0, so x can't be negative 2, or x can't be 2. So x can't be plus or minus 2. You can write it all together like that if you want to, but you can write it separately. It really doesn't matter. Okay, let's look at this one. That's getting kind of messy, isn't it? Yeah, we're going to pay attention on that one. Okay, so let's see what we got going. That's a quadratic. I'm pretty sure I'm going to have to factor it. Wait, I can factor. Yay! Okay. AC is 12. B is 7. So I need two numbers that multiply to get 12 and add to get 7. Yes, indeed, that is 3 and 4. I'll go ahead and put that in here. Plus 3x plus 4x, and that's my 7x. Okay. And then I'll copy around it. I'll factor by grouping. Both of those have an x, and what's left is, 2x plus 3. Both of those have a 2, and what's left is 2x plus 3. Oh, it worked. I got a 2x, the same thing in parentheses. So I'll factor out, undistribute the other ones, and that gives me this. So that's my denominator. That's my denominator. I'll go back and rewrite. Here's my numerator. I'm just copying from up here. But it's looking pretty good. And then here's my new denominator. Oh, look, just the same. Remember, we cancel things that are multiplied. These groups are multiplied. That they have an add or subtract in them doesn't matter because the group is multiplied. So these will cancel. You know, when you look at that, it just looks like something ought to be able to simplify. But no, it's lying in wait for you. Don't be suckered. There's nothing else you can do with that. Okay. That's the final simplified version. We need to find our excluded values again, and now it's going to be even more important. You have to go back to the original. So that's 2x squared plus 7x plus 6 cannot equal to 0. It's a quadratic, so I have to factor it. Oh wait, I already factored it. So it's x plus 2 times 2x plus 3 does not equal 0. Then either one of them. X plus 2 does not equal 0, so x does not equal negative 2. 2x plus 3 does not equal 0, so x does not equal negative 3 over 2. Those are your two excluded values. Okay. All right, you need to try some. Pause it and attempt these. Don't just attempt them. Be successful. Vanquish them. Okay? Okay, and here are my solutions, the way I worked them. Check them over. Make sure you see what's going on and work through them until you get to the point that you're comfortable doing each one of them. Okay. Let's look at that. It doesn't look like there's a lot of common things there. Seems like there ought to be something we can do with that. But whenever I approach one of these, the first thing I'm going to do is try to factor out anything that's common, undivided, undistributed. I notice that both of these in the numerator have a 6x, so I'm going to factor out or undistribute a 6x. X will be left minus 4. Then I'll look at the denominator. They both have a factor of 2 and they both have an x. And oh, how convenient. And what's left is an x minus 4. So again, the group is multiplied. So I'm canceling multiplication even though there's a subtraction inside because I don't care about that. You may want again to write these as separate ones. 6 over 2, which is 3, x over x, which is 1. Or you can, depending upon how comfortable you are with it, just go ahead and do it from here. So what's left on top is 3 and what's left on bottom is 1. So that's 3 over 1 and that's 3. You're going to need to find the excluded value. That'll be done the same way that we've been doing it. So 2x does not equal 0, and x minus 4 does not equal 0. There are your excluded values. Okay? Okay, time for you to work on it. Go ahead and pause the playback and give this a go. Okay, here are the answers the way I got them. Please look this over. Make sure that you're able to get the answers as well as the excluded values. Keep working at it until you're confident that you can do each one of them on your own. Next up, one more step. Oh my, that looks pretty messy. Both the numerator and the denominator are quadratics and they're not factored. So that's going to be like a pain to mess with. Let's see, how are we going to start? Well, I'm going to start with the numerator. Okay, the numerator. And I can factor. AC is negative 45. B is negative 4, and when I play with it and figure it off, or use the handy little trick I taught you on the calculator, you can see that negative 9 and 5 multiply to get negative 45 and add to get negative 4, so that's our two solutions. So go ahead and work on factoring this out. That'll be, I'll copy my original here, x squared minus 4x minus 45. Then the middle term is going to be composed of my 2 from here. So it'll be x squared minus 9x plus 5x minus 45. Remembering that this came from here. Then we'll factor by grouping. They've both got an x. X minus 9 is left. They both got a 5. X minus 9 is left. Ah, she shoots, she scores! The parentheses is the same. Yay! Okay. So then I'll factor out or undistribute outside ones, and I'll get this. That's my numerator. So I'm going to write that here's my numerator. And then I've got to figure out the denominator. What a fun thing. Same deal. Let's see. I can factor. 2 times 27 is 54. And negative 21. So A times C and B. B goes at the bottom. And when you play with this, you put it in your calculator. Do you remember how to put it in your calculator? Just in case you don't. Here's how you put it in your calculator. In case you want to remember. Okay? So I want them to multiply to be 54. So the things that will multiply to be 54, to find out, I divide 54 to figure out what will multiply to get 54. So I'll come in here and I'll go to y equals, and I want to know what will divide into 54. So I'll put in 54. I know that divided by x because that's what I'm trying to figure out. What will it divide by? That's what I want to know. So I hit enter. Oh, I know. What I'm going to do is I'm going to hit table, which is second graph. Let me see. That's a little better. Notice that that's dividing by 0, and that's not going to work, right? So go down and look at the ones that are whole numbers and see if they add to negative 21. Okay, well, one of them's going to have to be a negative. So, well, no, yeah, okay, so let's go this way. Add to negative 21. That's negative 55, negative 27. Look right there. Negative 3 and negative 18 add to negative 21. Those are my two numbers. Those are the numbers I'm looking for. Remember, that's the calculator shortcut for finding that. So, okay, I'll copy my denominator. Again, I'm working on my denominator. Here's what I started with. These are the two that go to make my middle term. I'm going to write them out here. Minus 18x minus 3x plus 27 again. This substitutes for that. The 21 turns into negative 21 turns into negative 18, negative 3. Okay. Then factor by grouping. Both of them have 2x. X minus 9 is left over. Both of these have 3, and x minus 9 is left over. Don't make that mistake there. It's negative 3 times negative 9, which is positive 27. You know that. I know, but you're going to make a mistake. Okay, you're going to go ahead and factor out or undistribute the outside portion. That's what we'll have. Okay, so now that is my denominator factored. And by the way, if you put a negative 3 first and then a negative 18, the only difference will be is they'll switch. Remember, it doesn't matter. You can cancel there, you can cancel there. It doesn't matter. They just happen to turn out to be on top of each other, so I'm canceling. I look at what's left, and I see on the top in the numerator, x plus 5, on the bottom in the denominator, 2x plus 3. And that is the simplified version of this rational expression. We'll need to find the excluded values, and it is important that we go back to the original. But as we've just practiced, I know that the original factors into this, and the first thing I'm going to do is factor it. So I'm just going to write it factored because it's the same thing. So it's the denominator, my original denominator, but I'm just going to go ahead and write it in its factored form. That doesn't change it, it just rearranges it. And I know that that can't equal to 0. So 2x minus 3 can't be 0. X minus 9 can't be 0. This means that x cannot be 3 over 2, or x cannot be 9. That's my two excluded values. Okay. Now you get to try some. Here you go. Pause and work them, please. Here is how I've worked the problems. Please look them over and make sure that you can get these answers. I have the simplified version and the excluded values. Make sure that you can work the problems to get these. And here endeth the lesson.